Okay, so today we are going to be talking about astronomy and the introduction to astronomy. We'll talk about a lot of things in astronomy. This is one of my favorite subjects, but we need to start off with this idea of how our ideas about the universe changed over time. Before we get started on that, remember red slides are the time to record your notes on your notes handout. And don't forget to look for the owl and tell me where he is. And last but not least, you're going to need to do a 2 to 3 sentence summary of what you learned. And now, the history of the history of the universe. Okay, so early astronomy looked quite a bit like this. People looking up at the sky and trying to figure out what was going on up there. And you can imagine that there was a lot of wonder and a lot of confusion and curiosity about what all those things were in the sky. Early astronomers were very interested in this. A lot of early astronomy had to do with religious ceremonies and things like that. Here is a shot of the Great Pyramids. The Great Pyramids are actually lined up to line up with the stars in Orion's belt. This is a picture of Stonehenge. Stonehenge is actually basically a giant calendar. The sun would line up with different stones at different times of the year, and this would help them to know when they should plant their crops. It would let them know when high tides and low tides would happen. It would let them know when the days were getting longer and shorter, things like that. So really important, this idea of using the stars as a way of figuring out what time of year it was. The ancient Chinese were really good at mapping out the sky. They were the first ones to make constellations, and they were also one of the first ones to map out when and where comets showed up. That's the picture in the lower right corner there. This is an astrolabe that was used in ancient Greece. This was a way of using the stars and lining things up to figure out where you were on Earth. So early astronomy had a lot to do with religious ceremonies and had to do with calendars, allowed you to predict seasons, tides, length of the day, things like that. This is a painting of ancient Babylonians marking positions of stars with rocks. So obviously this kind of meant something to them, and they would look at how the stars move across the sky. And I want you to look at this video that's about to play here and get a sense of how the stars move across the sky. All right, so that's a nice little video there, and you could see in that video, and you can see in this animation here, that it appears from our perspective that all the stars kind of move together. Now, we know at this point in time that that's because the stars aren't actually moving, we're moving. And when we change our position, it kind of looks like things in the sky are changing position altogether. So what you're seeing here is two pictures of the same part of the sky. And what you can see from one picture to another as they kind of switch back and forth, if you focus on this area right here, you can see that that one little point of light there keeps moving back and forth from one picture to the next. The rest of the points of light stay exactly where they are, but that one little dot kind of moves around. So early astronomers noticed this, and they called these special little points of light wanderers. And the name in ancient Greek for the word wanderer, the word that they used was planetes. And that's where we get the word planet from. And in fact, these were planets, and these were the early observations of planets. And what they saw was that the planets moved around in the sky differently than the rest of the stars. And on this next video that you're going to see here, I want you to kind of notice how the planets actually move across the sky. What you're going to see is a shot of Mars, and I want you to see how it moves along as it goes. Okay, so what you might have noticed about that was that Mars seems to move kind of across the sky in one direction, and then it switches directions for a little while and kind of goes backwards, and then it goes back in the same direction again. This is what we call retrograde motion. So early observations of the sky showed us that stars kind of move all together. But some stars seem to wander across the sky, and we now know that those weren't in fact stars at all. they were planets, and planets appear to move kind of differently in the sky. It's important to understand that the planet isn't actually moving in that way. It's not going one direction and then changing direction. This is all kind of a trick. It's all kind of an optical illusion based on the fact that Mars is moving and we are moving too. We'll talk about this more in class, but for right now, that's called retrograde motion, and draw this little picture in your notes. All right, you may see this little activity in your notes. We'll do that when we get to class. So, we need to talk about this idea of what our concepts of the universe were over time. And remember, the universe, when we say the word universe, we mean everything. Everything that exists, everything everywhere. And so our concept of this, you can imagine, as our knowledge and as technology progressed, this has changed quite a bit from back in the early days when people were just looking up into the sky to modern days now where we have satellites going off to the edges of the solar system and telescopes in space that can see the edges of the universe and things like that. We really know a lot more about things now than we did back then. But let's take a little journey through what we learned throughout the centuries. So one of the first guys to really kind of think about what the objects were in the sky was this guy, Aristotle. And he wasn't a scientist, he was more of a philosopher, which means he thought about things, but he didn't necessarily really do experiments and things like that. So he thought that objects in the sky moved on perfect spheres, and he didn't really attempt to explain this through any observations. He just kind of thought that this is the way things should be. Well, move ahead in time a little bit, and we get to this guy Ptolemy. The P is silent, by the way, so it's pronounced Ptolemy. He used scientific investigation. This is one of the first people that actually looked up in the sky and used measuring tools and took very detailed observations and notes of where things were in the sky and tried to use that to figure out how things were really moving and what these objects were. Based on this, he came up with what's called the geocentric model. And if you look at that word and kind of take it apart a little bit, you can see the geo part, which, like geology, means the earth. And centric, of course, means in the middle. So this is an idea that the Earth was in the center of everything. And it's very important to understand that what this idea meant was that the Earth was in the center of everything, and everything else, including the moon and the sun and the stars and everything, went around the Earth. And I want to show you this next little animation here, which will give you a sense of what he came up with as a model. And I want you to notice how complex it is. Okay, so this guy here is Copernicus, and Copernicus looked at the stars and he kind of came up with a different model. He basically said that the sun is in the center of everything and the earth is actually going around the sun, and he called this the heliocentric model. Helios is the name for the sun, and so heliocentric means the sun in the center. This was kind of a tough sell to the people at that time. You could imagine the idea that saying that the earth is moving is a little kind of difficult to believe if you don't have all the knowledge that we have today. Today we know that the Earth spins on its axis, and that causes day and night, and that it goes around the sun, and all of that kind of stuff. That's common knowledge now. But back then, the idea that the Earth itself was in motion really didn't seem right to people. But this ended up being a more simple way of explaining planetary motion. It was a simpler way of explaining all the observations we can make by looking up at the sky. And a lot of times, simpler explanations are better. This really was able to predict things in a much easier way than that complicated system that we just saw before. So the next guy we want to talk about is Galileo, and he was one of the first people to use a telescope for astronomy. He didn't invent the telescope, but he was one of the first people to use it for astronomy. And he made a really, really big, important discovery. And his discovery we're going to see in just a second here. But what he did was he basically proved the Copernicus idea that the sun was in the center. And the way he did this was he simply pointed his telescope up at Jupiter. And Jupiter has several moons, and 4 of its moons are very easy to see with a telescope. You can do it anytime if you want to with a very cheap telescope. You can see exactly what Galileo saw, which you'll see on the next slide here. And I want you to think about this idea of what that proved. Remember, The idea at the time was that everything went around the Earth. And Galileo simply took an instrument that many people had at the time, this telescope, and pointed it up at the sky and said, look, you guys can all see that there's objects going around the planet Jupiter, which means they're not going around us, so we're not at the center of everything. And this is really what got people to believe that the idea that Copernicus came up with. Okay, so now we get into sort of a more modern period in astronomy, and this guy is Edwin Hubble. And Edwin Hubble really kind of changed the way we think about the universe around us. So Edwin Hubble, this is the Hubble telescope, which was named after him. We'll talk more about this in class, but the Hubble telescope has been a very useful instrument in astronomy. It's one of the best telescopes that we have out there, and it was named after Edwin Hubble. So Edwin Hubble worked at this place that you see here, the Mount Wilson Observatory, which was one of the biggest telescopes that we had on Earth. And he was looking up in the sky, and he was looking at in particular, at the Andromeda constellation. And in the Andromeda constellation, there's a very interesting thing in there that was very confusing to a lot of people, and it's right there. So this is what's known as the Andromeda Nebula, or that's what they thought it was at the time. And it's important to understand that a nebula is basically a cloud of gas. And Hubble thought that this was just a cloud of gas that was within the range of what we now call our galaxy. But he was looking at it for a while, and he was debating with this other college who thought that it was something much bigger than that. They thought that it was actually its own separate galaxy. And after a while, through several different observations and pieces of evidence, Hubble actually changed his mind and ended up agreeing with this other group of people that thought it was another galaxy. They found out that it in fact was another galaxy, and so this really changes our idea of the universe. So at this point, we go from thinking that the universe is it's big, but it's kind of an understandable size, and it's maybe made up of a few 100 billion stars and things like that. But what we found was that what we thought the universe was, this 100 billion stars or so, is actually just one of many of these groups of stars that we call galaxies. And so the fact that this was a whole other galaxy basically told us that the universe is actually billions and billions and billions of times bigger than what we originally thought it was. And so this is a really big discovery and means that the universe is actually much, much larger than what we originally thought it was. So Edwin Hubble proved that the universe is much bigger, but he also proved another thing. He showed that the universe is growing, and we're going to talk about the evidence for this in class. But for right now, all you have to understand is that what Edwin Hubble saw when he looked out in his telescope was he saw that all of these galaxies that they had now discovered seemed to be moving away from us, which was very odd to think about. The hypothesis was that galaxies would all kind of be moving in random directions, some of them moving towards us, some of them moving away, some of them moving sideways, all kind of buzzing around like bees in a swarm. But when Edwin Hubble looked out at space, he saw that that wasn't the case. He saw that all of the galaxies were moving away from us, which told him that this is like a big explosion. Everything is moving outward. And if you take that idea and put it in rewind, that means that everything was in the past was smaller and closer together. And if you go all the way to sort of what we would think of as the beginning of time, then that means everything was packed together in a very small space, and at that first moment exploded, and we're kind of in the middle of that explosion now. So that idea that the universe is growing came from this, and that led to the idea of the Big Bang Theory.
How did the universe begin? Everyone knows the universe started with a bang. A bang so big, it's called the Big Bang. It happened everywhere in the universe at the same time and was the beginning of everything we know: space, matter, and even time itself.
Well, the thing is with the Big Bang, it wasn't so much actually a bang. In fact, the term Big Bang was kind of a bit of a joke, really.
But it wasn't really an explosion in the way that we understand explosions to be. It was something called a singularity, where time and space were sort of fused together, if you like. And then it was a period of very, very massive expansion, and that's why it's seen as an explosion. But technically and physically, it wasn't really.
So not an explosion as such, but it's what we think started, and it describes the evolution of how everything then came about.
In 1929, astronomer Edwin Hubble discovered that distant galaxies are moving away from us. And the furthest galaxies are moving away faster than the closer ones. So, logically, all these galaxies came from one tiny central point, what we now call the Big Bang.
The universe used to be much smaller than it is today. And originally the idea was it might have actually been infinitesimally small. But these days we tend to think of it as starting very small, but not actually at an infinitesimal point.
Further proof was found by two young scientists in the 1960s when their new radio telescope seemed to be faulty due to a constant annoying hiss. They checked the telescope from top to bottom and finally pinned the blame on some resident pigeons and their droppings. They swept the dish and evicted the birds, but the hiss was still there. This hiss was in fact cosmic microwave background radiation, or CMB, which is the heat and light left over from the Big Bang. It's traveled over 270,000 billion miles to reach us and has slowly cooled on its long journey.
The simplest way to think about it is like the echo of the Big Bang.
At the beginning of time, in the very early universe, all sorts of particles were created, amongst some the particles that you and I are made out of, and other more exotic particles, and as well, a lot of radiation was created at the same time.
It was kind of like a gas compressing and expanding until it reached a point where it became too cold for this expansion and compression to happen anymore.
And that point happened, I think, about 380,000 years after the Big Bang. And at that point, the signature of radiation started to seep out, and that's what the cosmic microwave background radiation signature is. In fact, we've all seen the Big Bang. About 1% of the static on your untuned TV is this CMB radiation. And scientists have used this static to calculate the age of the universe, which is roughly 13.7 billion years old.
Okay, so what we have now is an idea of early astronomers and how they did what they did and the tools that they used, and that this was mainly used for religious rituals and for calendars, and they kept track of the movement of the stars, and then they figured out that some of those points of light kind of moved around differently, and they called those wanderers, which we now know as planets. So, Aristotle, he was one of the first astronomers, and he kind of just thought about things and thought that it seemed logical that things move in perfect spheres. Ptolemy came along and actually did some science, used some observations, and came up with the geocentric or Earth-centric model of the universe. Copernicus came along and came up with the heliocentric model, but it wasn't until Galileo's observations of the moons of Jupiter that actually people started believing this idea. Edwin Hubble came up with a couple of very important ideas. He discovered that the universe is much bigger than what we thought, and he also discovered that it seems to be growing, which led to the idea of the Big Bang. We will go over all of the different types of evidence and more detail about this in the coming weeks.